Oh, okay. Yeah. All right, welcome everyone. It is August 9th, 2022, and welcome to our August edition of our OSM monthly meeting. Just as a reminder, this meeting is under the CNCF governance for code of conduct. If you're not familiar with what that is, there's a code of conduct file in the repo. So please make sure you're aware of that when you're interacting with everyone on the call. All right, so with that, let's go ahead and jump into it. I think we got a pretty interesting and exciting call today. We got the team from FlowMesh and they have a demo for us. So what I'm going to do is, as always, I'm going to go through some of the highlights from our last month, and I'll be talking about some of the what I think are some of the most interesting PRs. Again, if there are PRs that I don't list or highlight, please go ahead and chime in if you want to make sure that the community has awareness to those. Feel free to do that. Then once I kind of do the update of last month's PRs, I'll then go into kind of some of the highlights on the next scoped milestone, which is our view 1.3.0. And then if there's not anything else on the agenda, which I'm looking at, I'll then hand it over to the FlowMesh team. Before I jump into that, what we like to do is we do like to introduce everyone who's new to the community call. They want to go ahead and kind of just give a quick, shout out of the name, and then kind of, what they do, what they work on, what they're interested in. We always like to kind of just highlight people that are joining the call. So anyone can go at random. If not, I'll just kind of go down the list that I'm looking at.
Hey, I'm James, new to the community, and I work at Microsoft and helping out for a few months in OSM. I'm currently working a little bit on the server rotation and taking a look at how Spiffy and Spire might fit into our story.
Awesome. Thanks, James. We are really happy that you're deciding to give some cycles to this. Thank you. Let's see. I'm assuming I see Ado, Ali, assuming you two are from FlowMesh. Is that correct?
Yeah, that's true. Yeah, hi, Paul.
Awesome. You want to just do a quick
Ollie
intro?
here? Sure.
Yeah.
Sure, Ollie here. Yeah. I'm actually part of the FlowMesh team here, and today I'll be taking this on and actually to take the team through what we have put so far, and those kind of details there. So actually, I'm playing multiple roles here. Mostly I'm the technical evangelist, but also the solution architect here, working at the FlowMesh.
Awesome.
Right.
Thanks. Looking forward to that demo.
Yep, sure.
All right.
Oh, okay. Can I introduce myself?
Yeah, absolutely. Go ahead, Sean.
I'm from the FlowMesh team too. I'm Sean, and I'm currently working. I'm the maintainer of the Pipey project, which is the sidecar used in OSM Edge project.
Awesome. Thank you. Okay, let's go ahead and get into it. Big highlights for this month is we released our v.1.2.0. So I think that happened maybe a couple of weeks ago. So feel free to kind of look at some of the release notes. There's some good info, not good info, but yeah, there's some good features that are there, and they're all documented there. PR highlights from last month. Some of the things that I just picked off just through the filter is we added the global rate limiting. So that's, I know that was a well requested feature, and so we're happy for that to get in there and customers to start using some of those limiting features along with their applications. We did update the demo. So the demo is not in permissive mode by default. And we think that this really just kind of shows off OSM a little more as far as not being out of or not using permissive mode from the default. And we also have a GitHub Actions that is checking when you do create an issue, actually validating that you give it a size and a kind of a label. So again, this is going to help kind of the overall taxonomy of the issues and help people filter and kind of know what subjects issues are under. So we think that's really, really good for the project. And then lastly, enhancing kind of route certificate rotation. I know this is an ongoing effort. There's a couple of team members here that are working in that, and this is even continued through on our V1.3 milestone. So those are my highlights. If anyone else wants to chime in, any engineer that worked on something and they want to kind of let everyone know, feel free to do so. If not, I'll go into kind of what's on tap in the next milestone. All right, we'll keep moving here. Okay, so coming down is in our view.1.3 is our we're going to be adding UDP encryption support. And again, this next one here is again that whole certificate rotation story. We're going to continue to enhance that. And so, you know, all the links are here to those issues, the additional details. We're going to be simplifying the OSM release guide. And then we got several issues here around multi-cluster. We're really going to be kind of doubling down on multi-cluster. I'm not sure how far we'll get, but this is something that is a high priority for us in the project. We've gotten a lot of requests to have this type of functionality involved in OSM. So we're going to be a little more heads down on that in this milestone. Next, we have the custom trust domain support. This was another request from several customers that actually need the SAN name of their company name that comes from the CA. And so this will allow you to support that with the services deployed in Kubernetes. And then this next one is we're going to be improving the metric story in a couple of ways. I know we're trying to get a little more visibility from usability statistics about OSM. And so I know this is partial of that as well. So this is probably going to evolve. And if you got any like suggestions as far as usability stats that you think, like if we ultimately built a portal that you would like to see bubbled up in that, let us know so we can start to think about those and how we can go ahead and grab that data. And then finally, Windows container support. And this has kind of been mildly requested, but we maybe about a year or so, we did have a very raw demo of this. So it is doable. But what we're going to try to do this milestone is just really have maybe a solid MVP and then really get a lot of the community feedback to see, you know, which way we should go with this. So hopefully that'll be the goal for having Windows container support by the end of 1.3.0. Okay, so that is kind of, again, my highlights of what I thought we should let people know about 1.3.0. Any questions around the past PRs or anything that's happening in our next milestone, anything that anyone wishes should be there or they don't see? Go ahead and let us know. Okay, I think we're good. All right, I think this is the moment most people showed up for. Is I'm going to hand it over to the FlowMesh team. And actually, FlowMesh, who will be doing the demo?
I'll be doing that one. Ali here.
Okay, Ali, let me go ahead and I'm going to make you into a co-host here, so you'll be able to share your screen.
Sure. Right. Thank you.
That for you.
Yeah.
Okay. So you should have all those controls now. And with that, I'm gonna go ahead and stop my share, and floor is yours, Ali.
Sure. Thank you. Right. Okay. I'll just go to the desktop then. Okay, let me know. Are you able to see my screen there, right?
Yes.
Okay, I'll just go in a full screen mode. Okay, sure. Yeah, I know actually the clock is ticking for that one. So previously, actually, we prepared for a long time of that one. That we thought actually we might have some kind of maybe 30 minutes to an hour just to explain what has been done in that part. But later, actually, Saisha told us actually, there won't be that much time for that one. So what we have done here is that in the slides actually, okay, as you can see, the agenda is quite huge actually. So what I will be doing is actually I'll be skipping through some parts, and what I have done is actually I provided the links in each and every slide over there. So if the folks who are interested in learning more about that one, they want to know more, they can just quickly, they can click on those links just to learn more on that one. So just to be, the brief part,
Hey,
so why
hey,
was
Ali.
Yeah.
Hey,
Yeah.
Ali. Yeah. Let me just give you some comfort. So, we actually have more time if needed. I don't want you to feel
Sure.
pressed to kind of run through this. So we typically stop at the half hour, but we can go as long as you need to get this through.
Okay.
So yeah,
Right, thank you.
no pressure around trying to go through this super fast.
Sure. Right. Thank you. Right. So what I just try to put together, why was a match. So, and I believe actually the second part is what actually motivates the community here, because, mostly they are from the OSM. So what changes were made to the OSM actually, and why we come up with OSM match. And then I'll be taking this time to explain PyP, because PyP is the core. So as Shuang mentioned, actually, Shuang is the main architect and the main maintainer of this PyP. So PyP is the core of the flow mesh, to be honest, And then I'll be sharing some benchmarks which we performed, and all the artifacts, they are stored on the GitHub. So everything is available. Everything is online and open source. So the people, they want to redo things over there, so they can continue. And then I'll be sharing some kind of roadmap from our perspective. What we believe actually what we need to do. So that's just the stage for that one. Okay. So the background, I believe, because the edge computing, everyone is known that one, so I won't be spending much time. But I want to highlight is that one actually. This one is 2018 actually. The Gartner predict that by 2025, so almost 75%, the organization or the data actually that we processes. So we know actually, and we can see here in China actually we have a whole lot of actually the clients communicating, and we know actually the edge is actually the way moving forward. So that was actually the main factor for us, which we believe, why we should be trying to focus on that one. And I'll be explaining PyP later in that one. Actually, PyP, it started in 2018, and that was actually the main focus for the edge, cloud, and IoT. So that was the main reason. And edge, actually the benefits it brings, I won't be going through each one, but I believe decentralized and lower latency is the one actually why people are moving. And the use cases, what we are doing here is that because we are actually using OSM as well as PyP in multiple clients here. So just a disclaimer, I have removed actually the client information due to the NDA. So what you are seeing is Acme. Okay, so that's the reason. So I've just highlighted two use cases here. One is the energy client actually, and there actually we have actually participating in a pilot with that one actually. We are actually deploying a lot of ARM-based servers in that one actually, and we are deploying this the meshes to the POPs presence of points over there. And the other interesting point, I believe you'll be interested to know in that one, is the payments client over there. It's also a kind of a huge actually user base. So what they have actually done is that when actually they have been investigating the Istio for a long time in that one, but actually they were having some kind of issues with that, especially the resource consumption, and the memory consumption of the Istio, especially the NY. So that's the reason, and I just want to highlight here. I know actually, so we are not actually criticizing NY, or we're not criticizing anyone. So what we are trying to see, from a neutral perspective, why we moved to this one, why we use PyP, why we came up with this this operation. Okay, so that just set the stage with that. So you can see actually also in the benchmark, you will see that the PyP actually that uses very little resources. So our actually work with the client on this payment management. So as you can see, is half third of the CPU as compared to the Istio, and 1/5 of the RAM as compared to the Istio. So this OSMH is performing, and actually their clients they're still investigating on that one. But we can see kind of very positive feedback from the clients on that one. As I mentioned, that is the things change. So just to highlight here, because we based OSM Edge on the version 1.1.0 of OSM, and by that time 1.1.0 OSM was only available for x86. Okay, so what you are seeing here is based on those the information actually what we started over there. Okay, so so these things actually just try to highlight some few parameters there. And so in the middle there's OSM. When I say OSM, actually I'm talking about the OSM NY. Okay, and when I say OSM Edge, I'm talking about the OSM PyP. So the compatibility, because PyP is actually available on multitude of platforms, but OSM Edge actually is working on x86 and ARM platforms. And for that one, actually, OSM it uses NY, but OSM Edge actually it comes with PyP as the default, but we haven't removed NY. So NY is still there. So if, for example, if you download the OSM Edge CLI and you want to use the NY, do you want to use PyP? Sure, go ahead, and with that one you can use that one. So we haven't made any deletions. What we have done is addition. Okay, so resource consumption. So our actually benchmark shows that actually NY is very high on that part, and PyP is quite low on that one. And performance is same. So extensibility point, actually. So I won't be going in that details. But PyP, I'll be explaining in later stages over there. So PyP is actually coming with its own language. We call it PyP.js. So this is actually sidecar driver. So there's an issue 4874. So we have actually raised a very detailed issue along with also, there's also kind of document over there with step by step there. The reason actually we proposed that one because OSM is actually kind of tightly coupled with NY. So I do understand actually maybe the time actually started. So NY was the only options there. Okay, so but we identified actually, majority of the OSM is actually kind of implementation neutral. So you can I mean you can use in any other way, but there are cases where the NY is involved, so it is actually tightly coupled with that one. So the main thing is actually what we believe is a sidecar driver. So sidecar driver is actually the tightly coupled. So as you can see the pictures here, so what you are seeing here is actually is the change one, but initial OSM one is tightly coupled with NY. Everything you see is NY. Okay, so what we proposed in this solution, in this issue is that we should be actually separating out, we should be abstracting out the sidecar drivers. It shouldn't be tightly coupled with NY. Because when we say actually, we say open service mesh, OSM is actually a kind of, implementation neutral. It's not any kind of, specific to anything over there. So we believe only this, sidecar part is actually that is tightly coupled. So if we follow this kind of, refactoring over there, so any third party, they can actually come up with their own sidecar implementation without changing any of the code base there. So these are the two. So what we propose here is that when actually the sidecar should be abstracted out. So and we have actually in this issue we have shown POC. So we have shown actually what we have did, we refactored NY so that it uses actually this our refactored interface. And what we have done is we have also implemented PyP as a sidecar driver. Okay, so that actually shows the POC, this refactoring approach works. And the other thing is actually we're just, just trying to parallel, we just do some kind of static source code analysis of that one with the token, and we just generated a pie on that one. So what we identified is that one actually, you can see, the PyP sidecar implementation is based Go at the PTS, PyP.js is roughly half of the NY specific implementation. So that's why we say less is more. So again, we are not trying to criticize anything here there. Okay, but what we are showing the benefits, this kind of implementation brings onto the table. And then PyP, I will be explaining in the later slides what the PyP is. So actually every customization of the PyP is done by the kind of JavaScript or scale language. So if the reason actually we selected JavaScript was because it's a mostly used language over there, and the people actually they know how to use the JavaScript. Okay, and this is actually the core of the Flomesh there. So Flomesh actually have a whole lot of actually suite of open source you can say projects there. PyPy is one of them, and the other one is we call it FSM. Though we actually call it the Flomesh service mesh, it's not a service mesh, but it is actually a kind of the controller. It manages the north-south traffic as well as the multi-cluster support on that one. So FSM comes built in with the ingress controller. It's a full-fledged API, and we are OSM Edge actually we are using FSM as an ingress. But actually it also we are working on a way to apply the service networking, the gateway API, because currently now the gateway API actually moved to the beta version. So we are in the process of implementing the gateway API. So going forward, the people they can actually use the gateway API. And FSM is also kind of, it supports the multi-cluster. And what we are doing actually from the OSM perspective, actually we are actually implemented, the endpoint provider and the service provider for that one. So there's the FSM. And this is another kind of, the fun project actually, which we are, a few people actually they're trying to work on that one. So what we did is actually we are using the Kubernetes dashboard. So what we did is actually as you can see in the pictures over there. So we just try to add the service mesh, the portion of that one. So what it can do is actually if you already have service mesh installed, so it can identify and it provides support for or if you don't have that one actually via this the dashboard, you can proceed with the installation of the OSM Edge, or you can provide the mesh configuration changes on that one, and also it actually shows you the dashboard, the stats, metrics, and so on and so forth. Again, this is also open source one from the Flomesh. Okay, so that is the core part of what we call it, because PyPy is actually the core of that one. So a whole lot of all the projects and applications working in Flomesh under Flomesh organization is actually based on the PyPy. So I'll give you a very high level overview. So again, as you can see, every slide comes with the links there. So and those actually guide you to the location where you can find more on that part. So PyPy is actually PyPy. What we call is we call it a programmable proxy. So we also actually posted a blog post on InfoQ. Worthwhile programmable proxy actually where we try to explain why this new era is about the programmable proxies over there. So I'll definitely actually recommend people who have time, please do take a look at that one. So the PyPy is versatile in that one. So as you can see, actually, because PyPy has been used in all of the products, or the projects actually the Flomesh team is developing, be it actually for the IoT, or the edge, or the cloud natives in that one part. And this PyPy is fast. So it's to be honest, it's really very fast actually. PyPy, because it's mostly written in C++, and it's actually based on the ACO. From the boost on that one, and the other part is that one is we call it tiny. So the whole actually the compiled executable of PyPy is around 10 megabytes in size, and that is without any external dependencies. So all the actually the dependencies, for example, the OpenSSL and everything is actually we do a static compilation of that one. So you don't have to, there won't be any kind of conflicts over there. And the PyPy is programmable, and that's the core of that one. So we have actually kind of invented a kind of we call it the PyPy.js, and PyPy.js is actually the core of the PyPy there. And that's actually a tailored version of the JavaScript. So what we have done is actually we have removed the object-oriented parts of the JavaScript. So there are no prototypes and everything so there, but it's actually the functional. In PyPy, everything's an expression. Okay, so we don't have any statements in PyPy. Everything's an expression, so everything yields a values over there. And the PyPy is open source. So on the left side, actually, you can see there's 64K code base of the PyPy, and there's 50K 58K is C++, and the 6K for the JavaScript. That JavaScript actually refers to the GUI part, GUI. PyPI comes with, we call it the admin panel, and that comes with kind of, the IDE features where, for example, it has the IntelliSense. If you, for example, you can use the browser to write PyPI scripts. Okay, and PyPI is an IoT IT, and again, is built in GUI, that one, and the repo. Repo is another feature of the PyPI. So that's heavily used here in OSM Edge. Actually, is repo. You can think of kind of, like, for example, the GitHub way of doing that. We do have this kind of inheritance, everything over there, and all the code base is stored in the PyPI repo. Okay. So, and the PyPI.js. So as you can see here in the screenshots what we have captured here. So, and we have actually uploaded. Hopefully, I remember it was yesterday, or day before yesterday. Actually, we uploaded a video explaining, the PyPI.js as well, and the link is at the bottom of this slide. So the people actually interested. Again, just to highlight, it's a kind of subset of the ECMA standard, as I mentioned, and we don't support, the object-oriented part of the JavaScript. Okay, the PyPI benchmarks. So these are the benchmarks actually we performed against the Nginx. When the PyPI is used, a kind of, middleware, the reverse proxy, are kind of, some kind of a web server over there. So as you can see, actually, our criteria was, it was a simple benchmark. What we did is that, we had actually 4 Nginx workers, other PyPI instances of that one. And actually each worker, there was 200 simultaneous connection. And what we did, because we were using actually kind of, the JMeters and those kind of stress testing over, the software there. And file size was 0 bytes, and it was all actually kind of, short connections, so not keep alive HTTP connection. So the main thing is actually we just try to identify, because long connections actually they have their own some kind of, the edge cases over there. So we just try to do some kind of, the short connections over there. So when every time there's a new connection is established. So from the I mean, the results actually, you can see that, the PyPI is performing, is better than Nginx in the performance there. Okay, we use the default configuration of the Nginx. Okay, but and we also use the default configuration of that one. So we might be actually, because the benchmarks are just kind of for the reference perspective, perspective over there. So there might be some kind of the tweaks or some kind of specific settings you can perform to make the things better that one. So we didn't do, but we do the default settings over there. So we just want to highlight here is that in this kind of benchmarks on the default setting criteria, PyPI beats Nginx. Okay, and these are the sidecars. So sidecars, again, these are OSM Envoy and OSM PyPI. So here you can see actually, again, the source code is located here on the GitHub repo. So if the people that are interested to redo those kind of things, please go ahead and do that one. And there's also kind of the blog post which explain what we try to did and how we did that one. All those details over there. But again, you can see here again, the OSM PyPI is actually is much better than OSM Envoy. From be that TPS, no matter you're talking about or TPS or the RPS or that is the latency at the percentiles. And from memory consumptions there, so our actually again our results shows our benchmark shows actually, and the PyPI is actually using some kind of much less memory and also the CPU than its counterpart Envoy. And that's actually what we try to do or what we plan to do in the future. That's again because we started this, OSM Edge based on the code base of, OSM 1.1.0, but that actually we plan to sync, version 1.2.0 by September 30th of the OSM. Again, and also we have actually, FSM where we need to provide the endpoint providers for the multi-cluster and egress NAT gateway. So that is, for the 1.0 September 30th, our roadmap, for the OSM Edge. And then we have actually for 1.3.0 of 2x by end of December. Again, because we are doing it, our PyP release cycle is a quarterly release cycle. So there. And so 1.3 is actually, we plan to touch base on eBPF and DNS service discovery and Kubernetes gateway API. And as I mentioned, actually, because FSM actually fully supports the ingress and it supports a portion of the gateway API, but by end of this year, so we plan to support the beta version of the gateway API. And then again, we also plan to have the PyP, because currently PyP is in kind of beta versions. So it's still OSM Edge is using the 0.50 version of the PyP, but by the end of this year we plan to have the 1.0 version of the PyP, and also we are going to add the multiple protocols, especially the HTTP3 and the PyP and other protocols over there. Okay. That's all from my side, and for the demo, actually, we have actually put up a recording video on the YouTube. So please feel free to look in that one.
Hey,
Sure,
I want to just clarify something. So
sure,
PyP is, because maybe I was confused on one of the architect diagrams, but so PyP by itself, there's no envoy in PyP. Is that what I'm understanding?
that's right. There's no envoy.
Okay,
PyP,
that was okay.
That's right. There's no envoy.
Got it. Okay. Okay, that cleared it up for me. I was confused. I thought because when you're talking about, and then so the PyP JS, that is what you use to configure PyP the proxy. I'm assuming that's the language.
That's right. That's true.
Okay.
So this is the language. PyPJS is the language we use to configure.
Got it.
So you're right. So actually you can see. So as you can see here, if you look at the ToKaiPy, so that was the reason we put it here. So you can see the code base. So it's PyP configuration. Mostly what we do is actually, for example, the mesh catalog in the OSM. That's actually directly mapped to the JSON objects over there, and we use this kind of JSON actually in the PyPJS to do this kind of the customization, and the PyP comes with its own pipeline and the built filters out there, which we use that one. But you can see it's much easier. For example, if you have this mesh catalog over there, just generate a JSON object over there, and in the PyP you can use that way. Yeah.
Okay, and then PyP, I didn't look at the code base, but it's all compiled in Golang. Right.
No, PyP is
C++.
C++.
Got it.
Yeah.
Got it. Okay.
Yeah.
Okay. Okay. Thank you.
Thank you.
So we got a demo, correct?
Demo is actually I've recorded the video over there, so it's the same
okay.
demo.
Got it. Okay.
It's the same actually. The book buyer which OSM use, okay, and that's also the part of the demo or what we OSM use. As I mentioned, because we didn't remove anything from the OSM, what we did is we just add more things there. Okay, so
perfect.
What works in OSM, the same thing works in OSM Edge.
Got it. Okay, and I see you did update the link. There is a link out to the demo for those that actually want to see it. It's in the community notes. Perfect.
Yes, please.
Okay.
Yes. All right. Thank you.
Thank you,
Stop
Ali,
sharing
for
my
that.
screen there. Oh, thank you.
Yeah. Any questions from community about that, I know one question, Keith had to jump off, but one question was, are you going to be able to share the slides? Is there a link to where people can view these
It is.
slides?
The slides are there in the link. So
Okay, they're in the link as well.
Yeah.
Okay,
Yeah.
perfect.
Actually, I've uploaded the PDF versions and slides over there. Is there?
Okay, perfect. Okay, that answers that. Yeah, I'll open it up to anyone else on the call if they have any questions about what they're seeing. I want to ask Ali and the Flow Mesh team about anything.
Yeah, so the FSM component is kind of a control plane for all of the other meshes. Is that what I understood? Is like it's something a little bit higher level than just the mesh itself. Yeah. Okay.
Right. Yeah. For the multi-cluster part, yeah, it's a kind of control plane for others, as well. Yeah.
Okay, as well as a gateway provider.
Yeah, that's right. Yeah, it's a gateway provider. Currently, actually, we fully support, the ingress. So you can use the component of the ingress and the gateway, partial gateway. So we are working, to get the beta version of the gateway API.
Right. And so the mesh that you actually provide is OSM as a control plane with the PyPy.
That's right. Yeah. So cool. What we did is actually we use the OSM as the control plane, but the data plane is the PyPy, as a sidecar, right?
Awesome. Cool.
Yeah, that is cool. One question I had, so I'm just thinking about, and I'm going to go test this stuff out, but so sure. in a mesh, are you allowed to have a hybrid set of proxies, or do you have to choose Envoy versus the PyPy proxy?
That's a very good question. Actually, we had this kind of internal discussions here, but you have to actually choose at the kind of installation when you do OSM install. For example, if you use OSM Edge CLI, the default is the PyPy. Right. But if, for example, if you want to use the Envoy, then you can use the sidecar as the Envoy. So it won't be installing the PyPy. It will be using, the default version which comes with the OSM.
Okay. Cool.
And you mentioned the eBPF support is something on your roadmap. Are you doing that in PyPy, or is that how are you using that?
Definitely by PyPy, because we see the PyPy is actually the main core for all the things actually what we're doing at the Flow Mesh over there. So we'll be doing that one, just try to integrate, the things over there. So that, the peoples, they can use those kind of features by just the, the PyPy.js, So.
Yeah, that's interesting. So in the eBPF support, so will your proxies go away at that point? Is that what I'm understanding?
No, it's not going away, but actually, especially especially the kind of the traffic parts, how we're controlling that. For example, IP tables there, right? So we won't be using the IP tables to do this kind of stuff over there, right?
Got it. Okay. All right. Any other questions from anyone else while we have the Flow Mesh team?
I would ask one more.
Oh, yeah, go for it.
Sure.
So yeah, what? So I know that you put up that proposal for the changes to the OSM. To be able to make it flexible for different types of proxies. Is there any other changes or anything else that you would like to see come to OSM, or maybe as a proxy via your customers, kind of like, something that needs to be changed or added or modified?
No, because actually the thing is, again, we say that we didn't put that proposal just only because we do the PyPy, right? So that is one part of that, So because we know PyPy, but actually, as I mentioned there, for example, you can see in the use case you mentioned there, for example, the clients are using the Envoy based the meshes over there. So actually they are having those kind of the problems or the troubles especially the resource consumption and those kind of things over there. So those are the reasons reason actually we have to do that, so we believe actually there should be some more different ways of doing that one. And the reason actually we selected OSM, so to be honest, because OSM is really very well written, and it's mostly actually, I would say, majority of the code is actually kind of is implementation agnostic there, right? So any people, they can use that one. So but they're the cases actually which we believe actually it is very and relying on NY. We know it because we believe NY is just a kind of reference implementation for the OSM, right? So that's not the whole thing there. So we believe actually these are the things which need to be changed so that it makes us fully kind of implementation agnostic, and the peoples, they can read you can use a Linkerd proxy or any other proxies over there, right? So you can come up with their own ways of doing that, because there is no silver bullet, right? So NY is not everything. So there might be cases NY suits well, but there might be cases where NY doesn't suit well. So we want to give the people this kind of the selections or the options they can select which they want to use.
Awesome, thanks.
Yeah.
Thank you.
All right. Well, again, I want to say special thanks for Philomesh showing up. I know this meeting is not time zone friendly for you all.
Right,
so
right.
really appreciate you sticking it out and sharing this with the community. So again, thank you for that. With that, there's not any other questions. We'll go ahead and end the call. Our next call will be September 13th, same time. And again, I'll go ahead and create the next date in the community doc. And if you got any items or anything you wish to discuss, go ahead and just add that to the September 13th call. With that, we'll go ahead and end the meeting. Thanks everyone for your time. Thanks for showing up. And again, thanks for Philomesh for showing off.
Thank you. Thank you.
Thank you. Have a good day, everyone.
Thank you. Yeah. Thank you. Bye.